Now introduce the deep Q network for Atari games. When we use the reinforcement learning to find the optimal policy to play Atari games, we need to handle two issues. First one is feedback delay. That means when we take action A at the state S, we have to wait maybe several thousand time steps to see the feedback about the action. Second is input to the network is a raw image of the screen card. A Q network usually includes two networks. One is a Q network, another one is the target network. Q network uses loss function to find the optimal policy. Here, this is the target. So the target network is responsible for finding the target. We don't need to train the target network because we can copy the parameters of the Q network to the target network and run the forward pass to generate this target, use this target in the Q network, and then in the supervised miner to train the Q network and find the optimal policy. So once we have the loss function, then we can use a gradient method to find the optimal policy. Here we use the Salmon gradient. Salmon gradient means we suppose this target is no relation with the network parameters. When we calculate the derivative of the objective function, we only calculate the derivative of this part with respect to the model parameters. Here is the two networks. One is a Q network, another is target network. Q network uses the raw images as an input and to find the Q value over the action A, all the possible action A. And then now we know which one is an optimal policy. For the target network, we don't need the train. We just copy the parameters of the Q network to here and run a forward pass to generate the maximum Q. Use this Q together with the instant reward to get the target. And then use this target in the supervised miner to train as a Q network to find the optimal policy. Here, this replay memory, just this sampled on the emulator. Then we just get these samples. And when we train the network, we just randomly pick up data from here, make sure those samples are no relationship. Here is the code for the Q network. We run on episode, and we get samples on the emulator. And then we put in the dataset D. Here the function finds user to process the input to generate the same input format to the network. And then we just run target network to generate a target. This network target network generates the maximum Q, and together with this instant reward generate the target, and then use target through the gradient descent method to train the Q network, find the optimal policy. Raw Atari RGB images, the resolution is 210 and 160. And then we are only interested in the screen part area, so we reduce the resolution from this version to the 84 by 84. It's covered the enriching screen region. So this function phi used to process the last 4 images and generate 4 images. We stuck them together as the input of the Q network. There are 2 ways to design a Q network. One, the user, like here, we use the state and the action. Here is state, take action. We use these 2 as the input of the network and find the maximum Q. Because, from this state S and the policy pi, we have many action A's. So we need to run, if we use this way, we have to run, for each action, we need to run network, and then finally see which one is the optimal action to generate the maximum Q value here. This is the target that's inside the reward and the maximum Q by selecting action A prime at next state S prime. Another way seems more efficient, since we have a state here. Under the policy pi, we have so many options to select the action A. So in the network, we use the last 4 frames as the input of this network, and then generate the Q value over all the possible actions. That means one simulation, we can find which action is the optimal action that generates the largest Q value. I still use this as Y as a target to train this network. But this one, only for all the action, we need to only run 1 time. Here we need to run the number of actions times, to train this network. That's the, seems this way is more efficient. For more details, please check with the reference. Thank you. Bye.